right, guys, so welcome to this lab of VMware Hands-on Labs platform. So we are going to work with subject of deployment of Kubernetes-based applications on top of the VMware Cloud Foundation, particularly automation part of that. So let's just start. So this is hands-on labs environment built on nested infrastructure. So basically all hypervisors are virtualized on top of hypervisors deployed on physical. So let's just start with kind of environment overview. So yeah, of course, we have some bunch of things here like vCenter itself uh, for, let's say, management part of VMware Cloud Foundation and also workload vCenter. Of course, NSXs and then, I mean, NSXs for software-defined networking stuff and operations as a major path to operate all environment. Yeah, so basically we have three parts of this lab. It will be automation intro into the VCF automation part, then deployment of virtual machines using VCF automation, and then deployment of management of Kubernetes services also via VCF automation. Right. Okay, so of course, what will be interesting here will be a usage of concept of automation and particularly um, we have here setup where we are utilizing, of course, backend infrastructure. So vCenter with hypervisors, then we are utilizing cluster as a construct of vSphere. Then, of course, these days we are utilizing heavily as a major part to automate Kubernetes. So Kubernetes then is something which is called from a perspective of VMware as a supervisor. So that means on top of the cluster, we are enabling service of Kubernetes lifecycling plus deployment of cloud native applications. Yeah, so then we have some construct of region in more like perspective of automation part of architecture when organization then on top of that is utilizing region. Yeah, so region is pretty much like a set of resources from backend virtualization platform. Yeah, so until that moment we are talking about so-called traditional, let's say, or traditional administrator of infra. Then on top of that, we are then going into the area of really breakthrough of all the approach VMware is doing for consumption. That's a really, really important topic here. Really, VMware is just changing quite substantially approach how to utilize all architecture of virtualization these days, VCF in your cloud foundation. Yeah, so this is that kind of major construct here, which is called project. Yeah, so project is a kind of multi-tenancy approach to consume by multiple teams, whether those are line of business representatives or organization representatives, administrators. Of course, we are talking about technical roles. But actually, really, it could be even some platform engineer for cloud native applications. It could be partially, of course, developer. But basically, project is something which is providing us that kind of junction point where we are aligning between backend and consumption personnel, which is utilizing. We just want to utilize all that platform. So then project and as a part of this on the backend, this will be actually something which we are calling from the perspective of supervisor cluster, Kubernetes architecture, something like a vSphere namespace. So that means it's a bunch of resources from Kubernetes, let's say a core set of resources from cluster or bunch of clusters. Yeah. So yeah, that's really nice how now we can see complete end-to-end consumption architecture when it's much more convenient to consume, of course, some kind of hypervisors, vCenters, all that backend architecture, even supervisor, so Kubernetes, and what is really important also, NS6, which is not, exactly visualized here in this picture, but it's really, really important that we are also consuming automatically without any complicated visibility and operation stuff from NS6, software-defined networking. We're really just consuming it. So really simple, straightforward consumption to just go for your project and to deliver it as fast as possible. So this is the major stuff here. Yeah, and of course, as part of project, let's say actually from the backend, it's a vSphere namespace, so that means supervisor part of Kubernetes architecture. We are talking about virtual machines to be deployed. Then, of course, cloud native constructs, pods of Kubernetes, containers, and actually also applications itself or services, which then are predominantly these days deployed on top of cloud native containers. So really awesome how this is now implemented. So let's go for some other stuff here. Yeah, so actually we can just go for environment itself. So let's go for VCF automation. Yeah, so this is environment where we are accessing pre-existing automation. So which is a part of VCF stack. Okay, so we can see here all automation interface. So we can see a bunch of services, virtual machines, um, and of course Kubernetes based. So we have projects here. Those namespaces, vSphere namespaces named or mentioned in previous part. Uh, and we here can see also utilization. Yeah. So pretty much this is a high level overview based on namespace, based on project. Yeah, okay, so let's check it out. We have parts like build, deploy, management, orchestration, administration. Yeah, so we are going to build something here. And we can see some demos based on Kubernetes clusters. And we are going to work with construct of virtual machine. Right. Okay. So, and here we are really, and that's really important aspect of all this approach of automation and Kubernetes that we are utilizing Kubernetes to deploy virtual machines. So that's kind of uh, quite dramatic shift potentially for regular virtualization administrators because as we used to deploy virtual machines in a way to play with every each and customize and do whatever about that particular uh, kind of um, specific virtual machine of yours, and it was like a pet, playing with all details. So these days we are just traversing. I mean, not these days. It's quite for a substantial time already going on that we are deploying stuff based on some declarative approach. So that means repeatable approach, fully automatable and also trackable. Yeah, so something like desired state, which is used based on prescripts. Um, yeah, some kind of recipes we are submitting into the infrastructure. Then based on those, it's deploying stuff, updating stuff, life cycling stuff, including virtual machines. Yeah, so that's really, really important to understand this shift which is going on. And we can see clearly here that newest, latest, greatest stuff from VMware is doing all deployments, including virtual machines, via a usage of Kubernetes framework. Yeah, so same as we are working with Kubernetes deployments, we are working with virtual machine deployments using the same Kubernetes declarative approach. All right, cool. So then let's go for a creation of virtual machine. So what is really nice here is the fact that we are on the left side creating, let's say more or less standard way via wizard, as we are used from regular vSphere vCenter. But on the other side, we can see that we are creating code. Yeah, so clearly we can see here that we are working with API here, and the declaration is just providing some indications that it's Kubernetes, because as you can see here, there is declaration in YAML, which is of course used for desired state approach to deploy applications, and particularly on top of the Kubernetes, but not only on Kubernetes, other architectures. These days, though, we can see that this is really Kubernetes declaration. Yeah, so actually Kubernetes is going to handle virtual machine deployment. Yeah, so I mean, this is really changing the game. We are not going to deliver virtual machine as we used to for 2.5 decades with VMware, manually, semi-manually, or whatever kind of scripting. But here, this is standardized now on top of the Kubernetes. So this is really interesting stuff. Yeah, so we are going to deploy it into the particular namespaces. Namespace is a construct of Kubernetes, here also used in VCF automation to deploy to particular supervisor cluster. When in supervisor cluster of Kubernetes integration into the vSphere, VCF, of course, we are just dividing all the cluster of vSphere, which is the supervisor cluster, into smaller chunks, which are called vSphere namespaces. Yeah, so this is exactly this thing of namespace, which is Kubernetes construct, but also specifically on top of the VCF, it's supervisor vSphere namespace. Yeah, so NS apps project BBDJ 2. So spec, we have a bunch of things here based on the process of deployment. It's generating all those things like specifications. Yeah, so we will talk about those. We can see, of course, for example, storage class, yeah, which in this case is utilizing vSAN software-defined storage of VMware, which is, of course, a nice default option of all the concept of VCF. Of course, not only one, but fully automatable, nicely, fully integrated into the stack of software-defined data center. All right, cool. So let's just check it out, how this will work. So OVF, which is the open virtualization format, which is kind of image formatting, compression processing, packaging tool framework for let's say transfer of virtual machine across the places, sites. Yeah, so for this we are using image library, so-called content library from the perspective of VMware, vSphere, yeah, so or VCF. Yeah, so we are going to utilize what we have here as a Ubuntu, yeah, so Ubuntu operating system from a library, a content library, which is on the backend. Yeah, all right. So we can see nicely that as we are selecting this is automatically updating this entry here as an image name. Yeah, so this is really nice to see. And also friendly image name here automatically. Yeah, also what we are selecting is a class. Yeah, so t-shirt class. So what is the standard in cloud environment these days, of course. So I mean, doesn't matter when we are on a public cloud or private cloud, we are talking about classes typically. And so we have pre-configured classes for virtual machines. So can select some of them. Yeah, so without reservation in this case for CPU memory. Yeah, so best effort. That means it's just fighting for resources based on shares, prioritizations those virtual machines then have. Yeah, so this is the concept which is fully utilized in vSphere, VMware hypervisors, cluster concepts. All right. So it's simple. And then we are going to work with some creation of user for this machine. All right, so okay. So I mean those are options here which we are not going to utilize right now, but you can see that there are options to create load balancer, to attach persistent volume, so that means persistent data. In this case, as we are working with Kubernetes, then there is a construct of persistent volume claim from Kubernetes to be used for persistent data of virtual machine. Really, I mean, this is something which is indicating really a huge shift for VMware administrators. Yeah, because we are doing something like hybrid approach here, where we are delivering virtual machine, but uh, however, let's say, with the constructs of Kubernetes, which is typically persistent volume claiming. Yeah, so really important to understand this change. And then load balancer, as I mentioned, okay, so we have integration for load balancer. That's really amazing also, because then really we can just work with automation, full automation for virtual machine load balancing. So then automatically, as you will have multiple of those nodes, virtual machines, they will be load balanced. Yeah, so we have nice integration of external load balancer, for example, AVI load balancer, or as it used to be called, NSX Advanced Load Balancer. Yeah, so this is really awesome. But however, let's just go for a part where we have a user option here. We will create new user to just make some example of usage of automation. All right, so you can see really highly secured machine, really complex password. Okay. So we can see also this setup here, where kind of key for that user password is also defined. Yeah. So also, kind of definition for this password to be enabled. All right, cool. So that's really nice option here. Okay. So we'll enable authentication. You can see that really this is automatically updated here for Cloud Config Architecture framework uh, to just customize Linux image for deployment via the usage of Kubernetes framework. Yeah, so bootstrapping is completely editable, and you can define some custom stuff here even via the YAML directly. Yeah, of course, this is then reusable. Nice. All right. So what we can see here as part of Cloud Init definition is a set of those things like uh, host name. We are not going to handle this, and we'll leave it for those default values. Yeah, so host name, domain name, of course, and DNS servers. Nice. All right. So maybe it would be nice also to check it out uh, in from the perspective of a vCenter. So let's check it out here, what we have on the backend. All right, so right. So okay, so we can see here really the overall setup via the YAML. Plus, what I wanted to show is the backend system of virtualization. So then we have some part of all architecture, which is the management part, where we have a bunch of NSXs plus NSX software-defined networking management control plane and operation part plus vCenters. Yeah, so vCenter for management, which is this one where I'm right now, and then there is also workload part where we will deploy applications like we are now working on the deployment process. So then on the right side we can see workload. part. Yeah, so this is the set of 3 hosts here separated for workload deployments. And we can see here a part of the management part. Some difference, yes, and that's this part where we can see namespaces. Yeah, so we can see clearly that here we have Kubernetes running. Yeah, so that means in part of all this there is something which we are calling supervisor management. Later, latest version of vSphere, respectively VMware Cloud Foundation, where we can see supervisor. Yeah, so supervisor is that construct of Kubernetes, specifically crafted Kubernetes control plane. Yeah, actually, it's a special Kubernetes cluster, which is comprised of set of control plane, actually virtual machines running on top of the vSphere controlling Kubernetes supervisor cluster. Yeah, so actually, really, as I will just go for, let's say, all this setup. I can just then see in inventory that there is a supervisor cluster control plane, which actually in this case is one virtual machine, but in reality for production deployments is comprised of 3 nodes, supervisor control plane VMs. Yeah, so this is really specifically crafted Kubernetes control plane construct. Of course, virtual machines, machine as I mentioned. Yeah, so then also ZXCs now are working in hybrid mode. So that means they are a vehicle to provide resources for virtual machines, but also now those are actually workers of Kubernetes supervisor cluster. Yeah, so supervisor cluster is comprised from a control plane, supervisor control plane, and 3 workers. Yeah, so that's hybrid mode of hypervisors as we know it since last 3 releases of VMware virtualization platform. Yeah, so also we can see some other stuff here, which is related to networking. We are calling those edges for north-south traffic. Yeah, so this is something which we are utilizing as part of so-called NS6 deployment for networking. Right. Okay, so that's just a thing to maybe understand that there is some kind of backend architecture comprised from management part and workload part. So then let's go back. And let's finish deployment. And we can see that this is going to be deployed into the namespace NS apps project PBDJ2, which is here. And we can just start the process. Okay, so we can see now there is a process of deployment from OVF on the backend. All right, so we can see now a new object here created in vSphere. And we can see that virtual machine is managed by VM service, virtual machine service. Zone is specifically identifying supervisor cluster, resources cluster, specific cluster, as we can have a multi-site, multi-zone deployment. So that means we can deploy application in a highly available scenario when we can deploy each node of solution into different location, different cluster. In this case, we have one cluster. Okay, so we have also IP address. We can see it's real time updated here. Yeah, so 192.173.237.4. Same here. All right. So we can just SSH now into that machine. And of course, under normal circumstances, you are going to connect directly like this. Yeah. In this case, we have this kind of IP address deployed from supervised cluster, and this IP address is internal CIDR. Yeah. So really, this is by design. So I mean, generally with Kubernetes, as we have services deployed, they are from internal IP CIDR. Yeah, so in this case, we need to deploy also some kind of external construct to handle ingress communication of networking. Yeah, so really just a thing which is really becoming standard now for us as we are heading into this flavor of deploying virtual machines via Kubernetes. We just need also this construct of external load balancer or ingress service. Yeah, so let's just check it out, and we are going to do just work with this concept now of load balancing. Yeah, so we'll provide this external access Right, so let's go for it. So now we can check YAML. Nicely visible here. Of course, we can see also the deployment phase from the YAML here, down there. And can just check it out a little bit more here. All right. Yeah, so this will be kind of important thing because all Kubernetes stuff is based on selectors. Labeling, that's a major construct. Yeah, so in case we would like to expose, for example, service which is internal to be accessible from external environment, like we would like to have ingress communication, for example, then you are going to use label. Yeah, so in this case, label to be used for exposure of networking service via load balancer is this VM connection 7LBC, which is automatically generated. So basically, of course, I can make a note of this selector. Okay. So let's just go for a deployment process of load balancer now. Nice. Yeah, so this is really, really nicely integrated here. You'll see some set of services here which already have some setup for external IP. So, but let's go for it for virtual machine load balancer. Yeah, and we are going to create new one. So, of course, we can just customize. We will leave this with automatically generated name of virtual machine load balancer. We will create specific port to be exposed via load balancer. So let's just go for it. Yeah, so port 22, of course, on target also to be exposed on this port. Really cool. So now we should also see this one here. Like this. Yeah, so we can see definition here. Yeah. So okay, so the virtual machine service, and we can see definition for this load balancer definition from the perspective of ports here in YAML. Yeah, so there will be also IP address to be allocated. And we are going to use selector, yeah, because every time in Kubernetes, as you are going to expose service, you need to apply selector, so to expose particular set of containers, or in this case virtual machines, based on their labels. So we are going to edit, and we are going to utilize that specific label of virtual machine we deployed. Okay, so this one to be replaced. All right. So yeah, basically we can see the external IP address. So we can also check it out here. Okay, there is a mistake here, or thing I missed. Now we should see and expect association with virtual machine here. And now we can see. Yeah, so this is the moment of association with virtual machine. Nice. Right, so this should be now fine for us to try again, but now not against this IP address, which is again internal, but against the externally accessible IP. And voila, you just can see it's working. All right, so yeah, let's try. So nice, we are there. Inside of the machine. Yeah, so we can see it's that one with 192.138.237.4, but now accessed externally accessible IP, virtual IP of load balancer. Nice. All right. So right, as we are connected here via load balancers, we can check it out also from the perspective of backend, how this construct is situated, connected, how we can just check that load balancer itself. Yeah, so actually this construct is handled by NSX, software defined networking, which is fully integrated, fully automatable. It's API driven, really modern platform. So we can check it out as we have a hypervisor world of vSphere as XCs, runtime of virtual machine, as we checked that already here in well-known vSphere under the namespaces, Kubernetes implementation inside of the VMware Cloud Foundation. So handled by supervised cluster, all that stuff. But now let's check it out from networking perspective. Yeah. So yeah, we have regular IP address, which is internally accessible, but we need to just go for it from external. So NS6, that's the platform, and really we can check it out here that we can see visualization mapping. So basically there is some architecture of so-called perimeter of all software-defined networking, which is so-called tier 0 gateway, and that's connected to physical network. Yeah, and then we have some construct which is really unique now for new approach with so-called projects, as I mentioned right on the start. Where this is then from networking perspective related to the construct of so-called transit gateway. Yeah, so specifically crafted gateway to make it possible to connect to particular so-called virtual private data center or virtual private cloud VPC construct. Yeah, so this is a concept which is used also across industry of cloud IaaS, infrastructure as a service vendors. Yeah, so we are using this in our private environment. And we can see some specific gateway of this virtual private cloud VPC, where we then have connection to specific constructs. In this case, virtual machines, but it can be also Kubernetes construct. So Kubernetes cluster with pods, services, cloud native architectures. So in this case, we can see on the right one side Kubernetes, but now we are talking about virtual machines here deployed via Kubernetes supervisor cluster. So we can see virtual machine, that one which was created on the first part of the lab. Yeah, so we can see all details, but I mean, what is maybe more interesting is that part about load balancing. So we can check services and we can see load balancing there. Yeah, integrated. Yeah, which is automatically created. I mean, it could be a fully automatable or automatically created. In this case, it was created in a GUI of virtual machine configuration, but of course, it's YAML, then it's fully automatically deployed when you will reuse YAML. Yeah, so then no manual intervention required. So we can see there is a load balancer as a service of NS6. Yeah, so we can check it out also from perspective of created IP addresses here. Yeah, so we can see there is 10503 for 22 port. We can see the rest of them. Yeah, we can see also here, for example, for Kubernetes cluster, 6443, which is default for Kubernetes control plane communication. But in this case, 22, so that's exactly what is created by definition, which was executed previously. Yeah, so that's really cool. Yeah, we have full control of all the stack. That's amazing. So yeah, that's the thing here. All right, cool. So that was the thing. Thank you.